Hello everyone, welcome back to NIIT channel. Today I will take you through the fascinating world of agentic AI and multi-agent collaboration. These concepts represent the next step in artificial intelligence, where AI systems don't just process informations but act with autonomy, coordinate with other agents, and work together to solve complex problems. By the end, you'll have a simple yet clear understanding of what agentic AI is and how multiple agents collaborate and why this is becoming a game changer for the future of AI. Here's a quick roadmap of what we'll cover in this session. We'll begin by asking what exactly makes AI agentic. We'll compare generative AI and agentic AI so you can clearly see the difference. Next, we'll explore the building blocks, the components that make an agentic AI system possible. Then, I'll share some real world examples of AI agents and how they are already in use. We'll also look at multi agent collaboration and why having more than one agent is often necessary. After that, we'll discuss how to design and build your first workflow with agents. We'll highlight the benefits agentic AI brings to organizations. We'll balance this with a look at its limitations and challenges. Finally, we'll wrap up with key takeaways and a quick look at the future outlook. So let us get started by looking at where AI began and why agentic AI is seen as a next big leap. AI foundations, where we started. In the early days of AI, systems were largely rule based. These traditional AI systems worked within strict boundaries. They could only follow predefined instructions and handle problems in a very narrow scope. For example, a chess program could be built with the hard coded strategies, but if you asked it to analyze financial data, it would be completely useless. Then came generative AI or Gen AI, which we have all become familiar with over the last few years. Tools like ChatGPT, Microsoft Copilot, Google's Gemini, and others can create a content, text, images, music, even code based on the prompts we give them. Generative AI has been incredibly powerful for tasks like writing, design, brainstorming, and customer support. But here is the limitations. Both traditional and generative AI are reactive. They wait for us, the humans, to ask questions or give a prompt. They don't act on their own. This brings us to the next evaluation, agentic AI. Instead of just reacting, agentic AI can proactively plan and execute tasks. You can think of it as a journey. First, we had assistants that followed orders, then came agents that could take initiative, and now we are seeing teams of agents that can coordinate and collaborate, much like human teams do in organizations. Gen AI versus agentic AI. So, how do generative AI and agentic AI compare? Generative AI, as the name suggests, it's about creating content, code, designs, or data insights. It's powerful, but it's essentially like a very talented freelancer. You ask it to write an article, it writes. You ask it to design a logo, it designs. But once the task is done, it stops. Agentic AI, on the other hand, behaves like a digital employee. Imagine hiring someone who doesn't just create a content when asked, but who also understand the larger goal, breaks down the work into smaller steps, use the right tool and resources, collaborate with others if needed, and completes the task end to end. This is why we call agentic AI proactive. It doesn't just respond, it acts. And that makes it far more valuable in organizational settings where tasks are rarely one off. They often involve workflows, dependencies, and multiple steps that must be coordinated. What is agentic AI? So, what is agentic AI in simple terms? You can think of it as AI that works like a digital employee. It's not just a system that spits out answers, it's an intelligent agent that can observe the environment, make decisions, use tools, remember past interactions, and take actions to achieve goals. For example, a digital employee in customer support might not only answer queries, but also check your order status in the database, trigger a refund if needed, follow up with an email, and even escalate the case to a human manager if the situation requires it. The level of autonomy is what makes agentic AI different. It is less about responding and more about doing, and doing it in a way that resembles human initiative. Components of an agentic AI system. To understand how agentic AI works, let's break it down into its building blocks. An agentic AI system is not just one big model. It's a structured system made up of several interconnected parts. The agent is the brain. It decides what needs to be done, plans the steps, and chooses how to act. Tools are the agent's hands. These could be APIs, calculators, databases, or external applications the agents can call on to complete tasks. Memory acts like long term knowledge and short term context. It allows the agent to learn from past interactions and remember details across tasks. Without memory, each task would be like starting from a scratch. The orchestrator is like a team leader. If there are multiple agents, the orchestrator coordinates them, ensuring they don't duplicate work or step on each other's toes. Finally, there is the environment, the world in which the agent operates. This could be a customer service portal, a content creation workflow, or even a set of enterprise systems. When you put these pieces together, you don't just have a model, you have an autonomous system capable of real action. Single versus multi agent systems. Now, let us talk about the difference between the single agent and multi agent systems. A single agent is great when you have a very specific focused task. For example, an email classification bot that sorts incoming emails into categories like a spam, invoices, or customer request. It does one thing and it does it well. But many real world problems are more complex. That's where multi-agent systems comes in. In a multi-agent system, each agent has a particular specialty. They collaborate to handle problems that are too broad for any single agent. Think about a customer service team. One agent might route the query to the right department. Another agent might specialize in technical support. A third agent could handle billing and payments. Working together, they create a seamless customer experience. The power of multi agent systems lies in their ability to mirror human teams. Each agent is specialized, but when orchestrated correctly, they deliver outcomes that are more efficient and accurate than a single generalized agent could achieve. How multi agent collaboration works. Multi agent collaboration breaks down a complex task into a smaller parts through task decomposition. Each agent focuses on what it does best. That's agent specialization. These agents then communicate by sharing information and results with each other. A central coordinator or orchestrator ensures all agents work together efficiently by managing the overall workflow. Finally, all the outputs are integrated to form a complete and final solution. This collaborative system increases efficiency, scalability, and flexibility in solving complex problems. Let's see how this plays out with a practical example. Imagine you are asked to create a detailed market research report. If you rely on a single generative AI model, it might write an impressive draft, but the content may lack depth or a structure. With a multi agent workflow, the process is broken into steps. Just like in a real team, the project manager agent sets a goal, assigns tasks, and monitors progress. The research specialist agent gathers relevant data, trends, and key statistics. The technical writer agent takes that research, organizes it into a clear, well written report. Finally, the quality reviewer agent checks for accuracy, consistency, and readability. Each agent focuses on its area of expertise, and the orchestrator ensures smooth handoff between them. The result? A polished, professional report that's more reliable and detailed than what a single agent could produce. This is the essence of collaboration in agentic AI, mirroring the way humans work together, but at machine speed. So, to enable this kind of collaborations, we need the right technology pipeline. Let us take an example with the tools like a Crew AI, Streamlight, and OpenAI models. These allow us to create a workflow that is both functional and user friendly. The system can operate in two modes: agent mode, where we can see each agent's output step by step. This is great for transparency, debugging, and understanding how decisions are being made. LLM mode, where the system provides a fast, concise end-to-end results without showing intermediate steps. This is useful when speed and simplicity are more important than visibility. For a user perspective, the interface is designed to be a clean and intuitive. Progress spinner and status indicators show what's happening, and the results are presented in clearly separated sections. This kind of pipeline makes multi agent collaboration not just powerful but also practical for real world applications. So we can see the pictorial representations of your whatever we have discussed so far. Let's see a demo. This example is created with the tools like Crew AI, Streamlit, and OpenAI models. So let us take we have to enter our query here. Internally, it will be classified with this, either this LLM or agent will be execute this query here. So let me type this query here is what is the difference between supervised and unsupervised learning. So once we are provide this query, it is analyze it and it is classify the intent. Intent is detected as it will be answered by your LLM. So we'll be getting the direct answers from LLM for these type of queries here. We are getting the responses from the LLM. What is the difference between the supervised and unsupervised learning? It is a direct question. It will go to the LLM. Similarly, let me take this another type of a query. We can take it as here. Let me enter another query here. So in this query, we are going to make use of the multi-agents. Internally, it will be deciding, this query will be executing with the help of your multi-agent. We can provide this query is provide a detailed report. I need a detailed report on the latest trends in AI powered cyber security solution in 2025. After entering this query, you can see that it is classifying the intent. It is not answered by your LLM. It is answered by your agent here. So automatically the multi-agent processing started. Agents are working on your request. You can see the spinner here It is working on the multiple agent. So after a while, we are getting the result, final report generated by your agents. What is the output task from research specialist? You can see the output from the research specialist. This will be taken as an input for your technical writer. So the technical writer output will be taken as for the input for your quality reviewer. After reviewing by this quality reviewer, you will be getting the final consolidated report. You will be getting it. Whatever you are providing it, the query, based on the query, it will be intended as an LLM or your agent. So the multiple agents are working together. You will get the final consolidated report. You will be getting it. Designing multi-agent workflows. Now that we understand the components of agentic AI and how multiple agents can collaborate, let's talk about how to actually design a workflow. Designing a multi-agent workflow typically involves two main phases. Step 1, the design phase. Here we identify the task we want to solve and break it down into smaller, manageable steps. We decide which agents are needed, what each agent's role will be, and how they will interact with one another. For example, in a travel planning system, one agent may focus on flights, another on hotels, and another on local transport. Step 2, the implementation phase. Once the roles are clear, we connect each agent to the right tools and data sources. This might mean integrating APIs, linking to company databases, or providing access to structured data sets. Implementation also involves building the orchestrator logic so that agents know when to pass information along, when to work in parallel, and when to escalate tasks. A good workflow design ensures that each agent is both specialized and coordinated. Poorly designed workflows can lead to a redundancy, conflicts, or even contradictory results. That's why the design step is so critical before moving to technical implementations. To bring this to life, let us walk through a real world example, a multi agent travel planner. Imagine you are planning a trip. Instead of manually searching through the dozens of websites, you could rely on a system of agents that handle the process for you. The travel planning agent takes your inputs, origin, destination, travel dates, hotel preferences, and budget range. It coordinates the entire process. The airport agent recommends the best airports for your trip based on ratings, proximity, and reviews. Once the airports are selected, the travel planning agent finds suitable flights, filters hotel by location, rating, and price, and even compiles local taxi rates from datasets. The result is a consolidated travel plan that includes the recommended airports, the available flights, a filtered hotel shortlist, and estimated local transport fares. Technologies like Pydantic AI, Streamlit, and OpenAI makes it possible to build such workflows. Each agent works independently but contributes to the final integrated plan. What's important here is not just the automation, but the personalization. Users can set preferences like hotel ratings or price range, and the agents tailor the results accordingly. This shows how multi agent systems can replace tedious manual research with a seamless, intelligent planning experience. Let's see a demo. So this is a travel planner app. Here we are going to enter your origin city is, we can enter Delhi, we can enter from Delhi. We can provide your destination city as an Mumbai, and minimum hotel price is 3000 and maximum let it be as it is. The traveling date, let me choose okay 15 September, and minimum hotel rating, it is default is 4, let it be as it is. Now we are clicking the generate travel plan. With the help of the multiple agents, it starts generating the plan for us. So this origin airport recommendation is provided here. The best airport in Delhi is Indira Gandhi International Airport. It is providing. Similarly, the destination airport recommendations, it will provide you that. Then it will display the flight details will be displayed at here. What are the flights, at what time, what its price, all the details will be displayed. Then hotel details is also will be displayed it. Then from your airport, what is the taxi rate for the particular hotel? All this informations will be displayed it here with the help of your multiple agents. So this is a simple traveler plan. We can take all your details and it is generate the travel plan for you. Benefits of agentic AI. So why should organization care about agentic AI? What makes it worth the effort? The benefits are significant. Handling complexity. Agentic AI can manage multi-step, multi-domain tasks that would overwhelm a single system. Whether it's a travel planning, customer service, or financial analysis, these systems can bring together specialized expertise. Scalability. Unlike single agent systems, multi agent framework can scale across different functions. You can add a new agent for a new task without having to redesign the entire system. Specialized expertise, just like in human organizations, specialization leads to better results. Each agent focuses on its own niche and together they deliver high quality outputs. Efficiency and speed. Because agents can work in parallel and coordinate seamlessly. Outcomes are delivered faster and often with fewer errors compared to manual workflows. In short, agentic AI doesn't just automate tasks, it transforms the way work is done, unlocking new levels of productivity and intelligence for organizations. Limitations and challenges. Of course, as exciting as agentic AI is, it's not without challenges. No technology is perfect, and it is not important for organization to go in with their eyes open. Some of the key limitations include complexity of design. Building multi-agent system is more complicated than deploying a single AI model. You need to carefully design roles, workflows, and communication patterns between agents. Debugging and coordination. When sometimes something goes wrong, it can be difficult to pinpoint the cause. Was it one agent or was it the way the coordinator handled the interaction? Ensuring smooth coordination adds overhead. Conflicts between agents. Just like humans, agents can sometimes generate conflicting outputs. Resolve these conflicts require extra logic, often involving arbitration mechanisms or escalation to humans. Higher computational cost. Multi-agent systems typically requires more resources. Running multiple agents simultaneously, each with access to tools and memory, increases processing and infrastructure cost. So while agentic AI offers powerful benefits, it also requires thoughtful planning, governance, and resource management. Organization must weigh the advantages against these challenges before rolling out large scale adoption. Key takeaways and future outlook. Let's wrap up with the key points from today's session. Agentic AI is proactive, not reactive. Unlike traditional or generative AI, it can independently plan, decide, and act to achieve goals. The core components, agents, tools, memory, orchestrators, and environments are what make these systems possible. Multi agent collaboration unlocks solutions to complex multi step problems. Just like human teams, AI agents can specialize and coordinate to deliver better results. Real world applications are already emerging in areas like e commerce, content creation, and customer service. The benefits are substantial: handling complex tasks, scaling effectively, and enabling specialization. But the limitations are real: design complexity, debugging challenges, potential conflicts, and higher cost. Looking ahead, the future of work will involve not just humans and AI working side by side, but humans collaborating with the teams of digital agents. Organizations that embrace this shift early will be better positioned to innovate, scale, and compete in the next digital era. So the question is no longer if agentic AI will transform organizations, but how quickly we are willing to adapt and prepare for it. What are your thoughts on agentic AI and multi agent systems? Do you see them as the next major leap in AI, or do you have concerns about their implementations? Share your insights and questions in the comments below. We are eager to hear from your perspective. Are you ready to dive deeper into the world of AI and become a leader in this exciting field? Explore NIT's postgraduate program in AI and ML to gain the skills and knowledge needed for a successful career. If you found this video helpful and want to stay ahead of the curve in AI, machine learning, and tech trends, be sure to like this video, share it with your friends and colleagues, subscribe to our channel for more valuable content. Thanks for watching. We'll see you in the next video.